takes 5 minutes for them to solve a problem that would currently take supercomputers 10 septillion years.
Your phone thinks it understands you. Your email predicts what you'll say next. But here's what nobody tells you. AI isn't actually thinking at all. It's doing something way simpler and way more genius. For decades, we've been told two completely different stories. One says AI is a magical superintelligence that will eventually outsmart us all. The other says it's just a fancy calculator. Both are wrong. When you strip away the hype and the fear, AI isn't magic. It's not even intelligent. It's something you already understand. You just don't know it yet. In the next 6 minutes, we're breaking open the black box, and what's inside might surprise you. Let's go back 30 years. Back when programmers had to teach computers manually. Imagine you want to teach a computer to recognize a cat. So you write code. If it has triangular ears and whiskers and fur, then it's a cat. Sounds simple, right? Wrong. Show the computer a Scottish fold cat. It has folded ears. The system crashes. Show it a Sphinx cat. No fur. Crashed again. You just can't write a rule for every single exception in the universe. This is the problem that stumped engineers for decades. You can't code your way to understanding. So what changed? Instead of giving computers the rules, someone had a wild idea. What if we gave them the answer key instead? Introducing machine learning. This is where machine learning changed everything. Think of AI like a toddler. You don't teach a toddler the geometric definition of what makes a cat. You just show them 1,000 cats and say cat. Then you show them 1,000 dogs and say not cat. Eventually, the toddler's brain notices patterns on its own. It realizes, oh, that specific ear shape usually means cat. That furry texture usually means dog. Modern AI does exactly this. It looks at millions of examples and finds patterns so subtle that humans can't even describe them. But how? Making it real. Let's make this concrete. Imagine we're teaching AI to recognize the number 9. We don't tell it what a 9 looks like. We don't give it formulas or rules. We just show it 10 million handwritten 9s, then 10 million other numbers, and we let it figure out what makes a 9 a 9. At first, it's terrible. It guesses 2. We say, wrong. It guesses 8. Wrong again. But something wild happens when you do this millions of times. The AI starts noticing things. Not consciously. It doesn't think. But the patterns become clear. A circle shape at the top, a line at the bottom. That combination? That's almost always a 9. The assembly line inside. Here's where it gets interesting. The AI uses something called a neural network. Don't let the name scare you. It's called neural because it mimics the brain. But think of it differently. Think of it like a factory assembly line or a stack of filters. The first layer looks at pixels. It doesn't see a 9. It just asks simple questions. Is there a straight line here? Is there a curve there? It passes that information forward. The second layer combines those observations. It says, hey, that curve at the top, that's a circle. That line at the bottom, that's a vertical stroke. Finally, the last layer puts it all together. Circle on top plus line on bottom equals probably a 9. This is deep learning, just layers stacking on top of each other. But here's the million-dollar question. How each layer builds. How does the AI know that a circle on top means 9 and not 6? This is the genius part, and it's way simpler than you think. Imagine a giant mixing board, billions of knobs. Every single knob controls something tiny, a small part of how the AI sees the world. When the AI is born, its brain is empty. It's garbage. If you show it a cat, it guesses toaster. Completely wrong. But when it gets it wrong, something happens. The system sends a signal back through the network. We call this the feedback loop, and it's about to change everything. Hot and cold. Remember playing hot and cold as a kid? You'd hide a toy. Someone would search. They'd guess. You'd say cold if they were wrong, hot if they were close. AI learns the exact same way. When the AI guesses wrong, the system sends what we call a cold signal. It says, You were wrong. Adjust your settings. Those settings? We call them weights, parameters, the knobs on our mixing board. Every time the AI makes a mistake, it tweaks the knobs. Just a tiny bit, microscopically small. But then it tries again, and again, and again, millions of times. Each time adjusting those knobs fractionally, getting slightly better feedback. Eventually, and this is the magic part, all the knobs are tuned perfectly. A cat picture goes in. The word cat comes out. The AI doesn't understand cats. It's just tuned its mathematical dials to react correctly to pixels. When AI writes and creates. But wait, what about AI that writes essays? That creates art. That sounds like thinking, right? This is generative AI, ChatGPT. And the logic is different. Instead of true or false, it's playing fill in the blank. Imagine you've read every book in the Library of Congress. I say, the quick brown fox jumps over the. You know the next word is lazy. Why? Not because you calculated it, because you've seen those words together 1,000 times. The probability is 99% that lazy comes next. Generative AI is a superpowered autocomplete. It looks at the words you typed. It checks its massive database of human language. It calculates the statistically most likely word to come next. It isn't sharing truth. It's predicting the most probable sound a human would make. What AI actually is. When you look at AI, it feels like you're looking at alien intelligence. But the reality is way more grounded. It's a tool, built on logic, built on trial and error, built on a massive amount of human data. It doesn't possess wisdom. It possesses experience borrowed from us. It isn't magic. It isn't intelligent. It's the simple thing that became complex just by doing it 1,000,000,000 times in a row. A pattern-matching machine. Nothing more. Nothing less. Abrupt ending. But here's what keeps researchers up at night. We don't actually know what happens when you scale this up. What happens when you have 1,000,000,000,000 parameters? When you feed it the entire internet? When you make it 1,000,000,000 times more complex? Does something change? Does it suddenly become conscious? Does it actually start thinking? We've created something that mimics intelligence so perfectly that we can't tell where pattern matching ends and actual thought begins. And the scariest part? We built it without fully understanding what we built. AI companies are racing forward. Governments are scrambling to regulate it. And the fundamental question remains unanswered. What happens when the pattern becomes too complex to break?